In this video, we're going to take a look at some additional logic functions in Excel. Specifically, in addition to if, we will also talk about the and, the or, and nested if functions. We'll start with this list of employees that we've used in previous videos. Notice that we have, in addition to their name and general information, we have their tenure, which is how many years they've been with the company, their GPA, and their salary. So we'll start with a simple example. Let's suppose that we're going to give a $5,000 bonus to everyone who's been with the company more than 15 years. And for anybody that's been with the company less than 15 years, we'll give them a $1,000 bonus. So here we'll type in bonus, and we'll use an if statement to say if their tenure is greater than 15, give them $5,000. Otherwise, give them $1,000. We use our format painter here and then copy that formula all the way down. And you'll notice that each of those that are under that 15-year mark get $1,000 and above 15 gets $5,000. This person right here, Frank, gets $1,000. He's been there for 15 years, but the formula we wrote says he has to be there greater than 15 years. Now, to take a different example here, let's call this one bonus 2. We'd like to give a $5,000 bonus to all the employees that have been here more than 15 years, or if their GPA is over a 3.5. So to do that, we'll type in the if statement again, and this time our logical test will be done within the or statement. And the or statement evaluates whatever logical conditions are put in it to determine whether any of them are true. So in this case, we would say tenure is greater than 15. That's our first logical statement. Our second logical statement would be that GPA is greater than 3.5. If either of those things are true, then the or function will return the value true, which means that we want the if statement to return a $5,000 bonus. And if both of those things are not true, we only want a $1,000 bonus. Again, we use our format painter here and drag that all the way down. So you'll notice that Edward here only has a tenure of 7 years, but his GPA is over 3.5, therefore he gets the $5,000 bonus as well. The AND function works very similarly to the OR function. It requests multiple logical statements. The OR function returns a true value if any of those logical statements are true. The AND statement returns true only if all of those logical values are true. To demonstrate the AND statement, let's take this format here and we'll call this bonus 3. Now we'd like to give a bonus only if they've been with the company more than 15 years and they had greater than a 3.5 GPA. So again, we'll start with the if function, and this time we'll use the AND statement. The first logic is that their tenure has to be greater than 15. The second logic is that their GPA has to be greater than 3.5. Now, both of those conditions have to be true in order for that logical test to return the value true. If both of those conditions are met, and this returns a true value, we'd like to give them 5,000. If not, we'd like to give 1,000. Now, the examples that we've done so far use only 2 conditions, but we can, with those and or statements, use a number of conditions that's almost virtually unlimited. If we start with the if function and we use an and statement, we want to be able to say that the tenure is greater than 15 years and the GPA is greater than 3.5 and their salary has to also be greater than, say, $39,000. If all of those are true, we'll give them 5,000, otherwise 1,000. And now in this case, only one person receives a bonus here. It seems that in this instance, supply chain is a good career choice. With and or statements, we typically use those inside of an if statement. They can be used on their own, but the if statement helps us to know what to return if those return a true or a false value. We'll finish this video talking about the nested if function. Let's suppose that we want to assign these bonus values in tiers. let's come over here to the side and we'll set up the rules for our tiered bonus system. In this case, we'll start with the number of years at the company, and then over here we'll give the bonus amount. So if someone's been there 5 years, they'll get a bonus of $1,000. Please take a moment to fill in your spreadsheet to match this payout table. So these are the rules for our tiered bonus system. If we label this column here bonus 5, we can go through a nested if function where we start with an if statement and we say if the tenure is greater than 30 years, we'll give them $10,000. Otherwise, if that's false, we're now going to enter an additional if statement to say if their tenure over here is greater than 25 years, then we will come over here and give them $7,500. And we'll continue this logic through all the way through until we get up to that very top of this chart. So over here, we now want to say if that's false, that they haven't met the criteria for 30 years and they haven't met the criteria for 25 years, we'll do another if statement and we'll say if their tenure is greater than 20 years, then we'll give them $6,000. Otherwise, we'll check again and say is their tenure greater than 15 years? If it is, we'll give them this $5,000 over here. If it's not, we'll check again and see is their tenure greater than 10 years? If it is, we'll give them this $2,000. If it's not, we will check one more time and say that their tenure is greater than 5 years. And if that's true, we give them $1,000. If none of those things are true, then we would give them $0. And now we have to close up all of the parentheses from those if statements. So the first if statement is closed with that, then the next, and you can see the parentheses kind of get a little bit bold as we close them off. And then one final one, and we press enter. Now we check the logic to see if it worked. Here we say their tenure is 28 years, so they should be getting between 25 and 30 years here. They haven't quite gotten to 30, so at the 25-year mark, they qualify for $7,500. If we use our format painter here again, we can drag that function down, and we'll see that all of that failed because we did not anchor. So over here, when we reference this table over here, we have to make sure that we're anchoring appropriately. So what we can do is we can use our F4 key to go and fix this. Now we don't want to anchor anything in column E because we want that to slide down as we drag. But we do want to anchor all of these references over here. So we'll just click through each of these and press F4 for anything that's column P or column Q. And now when we press enter, nothing will change on that row, but as we drag down, it will correct itself through the rest of the rows. And we can spot check a few of these. Someone's been here for 7 years, so they haven't quite gotten to that 10-year mark, they get $1,000. This person's only been here 3 years, so they don't even get the $1,000 mark. And that's how you can use a nested if statement to evaluate multiple criteria. I'll close by showing you one more method to accomplish this same thing with a much simpler formula. So if we take our format and we add this to this next column here, and we'll call this one bonus 6. We'd like to follow the same logic as we just did with the nested if statement, but we'd like to do it without having to write so many if functions, because writing all of these, you could get lost and make a mistake very easily. So what we can do is use a little trick with the match function. We'll type in match, and the lookup value we'd like to look up is 28. But 28 doesn't exactly exist in this table. And so when we choose our lookup array, which we will anchor, instead of choosing a match type of 0, which is an exact match, we're going to choose a match type of 1, which means less than. And this finds the largest value that is less than or equal to the lookup value. The thing to be aware of here is that the lookup array must be placed in ascending order, meaning that it goes from smallest to largest. And in this case, we've done that. So we'll enter number 1 and we'll type close parenthesis here. Now it returns a row number that this matches. So it's saying we found a match for 28. It's row number 5 in our array. So row 1, 2, 3, 4, 5 gives us 25, which is the correct row for that 28th year associate. Now we'll wrap this inside of an index function. And the index function wants to know what array should I pull information back from, which will be this bonus column right here. And we do want to anchor that, so we'll use F4 to anchor those in place. And now we'll type in close parenthesis and hit enter. And as we drag this down, what you'll notice is there are some slight differences. One is that here, this marketing manager with 20 years of tenure is getting a $6,000 bonus here, but a $5,000 bonus here. And that's because of a difference in logic. In this if statement, we said it had to be greater than whatever the number was. And you'll remember in this example, it says that it finds the nearest one that is less than or equal to. So you could achieve the same outcome if you change the years to be one number off so that a less than or equal to would be equivalent to what we see here by using the greater than function. The other error that we see is right here, it can't find anything less than 3, and so it doesn't know what to return. It returns an error. So we can fix that error by wrapping this in an if error function and saying to return 0 if you can't find anything. And then we let that go all the way down. So you'll notice here, with this error checking and all of this formula, compared to this nested if statement, it's a much simpler formula and it's less error prone than this nested if. Of course, there are these differences here that you have to recognize the logic may need to be slightly different in how you structure your table, but the same result can be accomplished without having to go through and create all of these levels of nested ifs. There are some cases where the nested ifs are necessary, and that's the right way to go. But I wanted to show you one more option as you think through how you might solve the types of problems that you face using logic in Excel.